Hello everyone, this is Miss Imat once again. For today's video, we will be focusing on the last part of lesson 5.2, function tables. And this part will be about real-world applications of linear functions. Before we go to the main discussion part of this video, let's have a quick revision about graphing linear functions, which we learned in the previous video. Okay, so we are given here a function y equals 6 minus 2x. And we have to complete this function table. Based on what we have learned in the previous video, what we have to do is to substitute the x values in these values to the x in our equation. And then we simplify to get the output. So let's do that now. If x is equal to 0, then we have to exchange this to 0. We will have 6 minus 2 times 0, which will be 6 minus 0, which will be 6. Okay. For the second one, we will have 6 minus 2 times 1, which will be 6 minus 2, equal 4. Then we have 6 minus 2 times 2, equal to 6 minus 4, which is 2. Then we have 6 minus 2 times 3, which is going to be 6 minus 6 equal 0. Then the last, we will have 6 minus 2 times 4, which will be 6 minus 8, and then would equal to negative 2. And this will be our output values or our y values. So I can just copy it here, 0 and negative 2. Now, we're finished with our function table. The next step is to graph these points. Now that we have finished creating our function table, we can now graph the points that we have in our table. Okay, so we have 0, 6. Again, the first thing that we have to do before we graph is to write in the values in our Cartesian plane. So this will be 4, the negative values on the left side. And then for the y-axis, we have positive values in the upper part and negative values down. Alright, now we can proceed to graphing our ordered pairs. The first one, we have 0 and 6. 0 in the x value, and then 6 in the y value. Okay, we have only here until 4, so I can extend that. 5 here and 6. Let's place it here. Now our point will be here. Then for the second ordered pair, we have 1 and 4. 1 in the x-axis and 4 in the y-axis. If you will trace a line over these two numbers, we will have our ordered pair or our point in here. Then 2, 2. 2 in the x-axis and 2 in the y-axis. These two lines will meet here. So our ordered pair will be here. The fourth ordered pair that we have is 3, 0. So 3 in the x-axis and 0 in the y-axis. So our point will be here. Then last but not the least, we have this ordered pair, 4, negative 2. So you have to have 4 in the x-axis and negative 2 in the y-axis. These two will meet around here. Okay, now the last thing that's left to do is to trace these points. Now we know that this is a linear function. So if you have a ruler with you and you're graphing, this should come as a straight line. Now let's go to our main topic for this video, which is about application of linear functions. Let's have the first example so we get to understand this better. Now the first example is, a computer store charges $45 for materials and $50 an hour for service to install 2 new programs and a connection. The function C equal 45 plus 50h represents the total cost C of the number of hours H. So C means the total cost and H means the number of hours. Now, how much does the customer pay if it took the serviceman 3 hours to install the programs and the connection? So what we have to do is, this is our equation or our function rule. It's C equal 45 plus 50h. Now it's asking how much. So we're solving for the C here. Remember that the C is the total cost and H is the number of hours. So we are actually solving for C if the hours is 3. So what we have to do is to exchange H with 3. Okay, we substitute H with 3 and then we simplify. Okay, let's do that now. We have our solution to be C is equal to 45 plus 50. Then again, I will exchange H with 3. When I simplify this, I will have 45 plus 50 times 3 will be 150. And when I simplify 45 plus 150, I get 195. So C is equal to $195. This is how much the customer has to pay if it would take the service crew 3 hours to install the programs and the connection in their house or in their workplace. Let's have another example. Okay, example number 2. An elephant weighs 200 pounds at birth and gains approximately 2 pounds per day. The function W equal 2D plus 200 represents the weight W. So the weight of the elephant is the W on a given day, D, during his first year. How much more does an elephant weigh on day 60 than it does on day 5? Okay. Now, how do we solve linear functions problems like this? So it's asking for 2 things. First, you have to solve for the weight of the elephant after. So W, okay, let's have W when D is equal to 60. It means that we have to solve for the weight of the elephant when the day is 60, when he is born after 60 days. And then the second thing, we have to solve for the weight when the day is 5 or 5 days after the elephant is born. Now let's do this now. So we have the equation W equal 2D plus 200. Now to solve for W, we have to exchange D with 60. So 2 times 60 plus 200. When I simplify this, I will have 120 plus 200. And then the final answer would be 320. So the actual weight of the elephant after 60 days would be 320 pounds. This is after 60 days. Now, how much does the elephant weigh after 5 days? We do the same thing. So this is our equation. The only difference is we now would substitute 5 instead of D. So it would be 2 times 5 plus 200. Then we will have 10 plus 200, which will give us 210 pounds. This is the weight of the elephant after 5 days of being born. Now, the final question is, how much more does the elephant weigh on day 60? So, at day 60, it weighs 320 pounds. And then on day 5, it weighs 210. So, what is the difference between these weights of the elephant? So, what we have to do is simply subtract 320 minus 210. And the answer would be 110 pounds. This will be the difference between the weight of the elephant in these 2 different days. Let's have our last example for this video. Okay, example number 3. A taxi service charges $2.50 plus $0.75 per mile. The function y equals 0.75x plus 2.50 represents the total cost y. So our total cost is y of a taxi ride for any number of miles x. So x is represented by the number of miles. If Adriana rode 10 miles in the taxi and Alonso rode 15 miles, how much more did Alonso spend on his taxi ride? So this problem is almost the same as the previous one that we just answered. So we have to solve for how much Adriana paid the taxi and how much Alonso also paid the taxi. So let's do that now. For Adriana, she rode for 10 miles, while Alonso rode for 15 miles. Okay, now we have our equation, and that is y equal 0.75x plus 2.50. Now, we know that the miles is pertaining to x. So what we have to do here is to exchange the x with 10. And for Alonso, we have to exchange or substitute the x with 15 miles. So let's do that now. So I will have here 0.75 and then x will be 10 plus 2.50. Simplifying 0.75 times 10, we will have 7.5 plus 2.50. When you add this, you will get 10. So it means that Adriana paid $10 for the taxi service. Now let's compute for how much Alonso paid. So we have the equation 0.75x plus 2.50. Okay, Now we have to substitute x with the number of miles, which is 15. So we will have 0.75 times 15 plus 2.50. Simplifying further, we have 0.75 times 15, and that is 11.25 plus 2.50. The answer would be 13.75. This is how much Alonso paid. Now, the question is, how much more did Alonso spend on his taxi ride? So it's asking for the difference from the fare price of Alonso and Adriana. What you have to do is simply subtract these two amounts. So we have 13.75 minus 10. The answer is $3.75. This is how much more Alonso paid for his taxi compared to Adriana. Okay, so that concludes this video and that lesson, lesson 5.2. So we've already covered all the parts from 1 to 4, and this is the last one. Okay, I hope you have your copybooks with you, because now you will be answering one practice exercise as your classwork. Copy and answer the following in your copybook. So you have the word problem here, and then you have to answer the question that is included in the word problem. Remember to always show your solution. Again, this is Miss Imat, your teacher guide for today. Till the next video, happy learning!